We're given f of x equals 6 divided by the sum of 1 and x squared for x greater than or equal to 0. Number 1, we're asked to find the slope of the tangent line to its inverse function at the point 3, 1. If the point 3, 1 is on the inverse function, we know that f inverse of 3 is equal to positive 1. We should also be able to make the connection that this also means that the point 1, 3 would be on the graph of the original function, meaning f of 1 is equal to positive 3. But let's go ahead and check this. Let's determine f of 1 here on the side. F of 1 is equal to 6 divided by the sum of 1 and 1 squared, which is 6 divided by 2, which is equal to 3. Now to determine the slope of the tangent line to the inverse function at the point 3, 1, the slope, m, is going to be equal to f inverse prime of 3, the derivative of the inverse function at x equals 3. Instead of determining the inverse function and then finding its derivative, and then evaluating that derivative at x equals 3, we'll use the fact that if f of a equals b and f inverse of b equals a, then we can find the slope of the tangent line using the formula shown here, where f inverse prime of b is equal to 1 divided by f prime of f inverse of b. And since f inverse of b is equal to a, we can say f inverse prime of b is equal to 1 divided by f prime of a. This formula is telling us that the slopes of the tangent lines or derivative function values of f of x and f inverse of x are reciprocals of each other at corresponding points. Applying this formula in our case, we have f inverse prime of 3 is equal to 1 divided by f prime of f inverse of 3. We know f inverse of 3 is equal to 1, giving us 1 divided by f prime of 1. So to find the slope of the tangent line of the inverse function at x equals 3, we need to find the slope of the tangent line to the original function at x equals 1, and then find the reciprocal. So let's work on determining the derivative function f prime of x so we can find f prime of 1. To begin, let's write the given function f of x as f of x equals 6 times the quantity 1 plus x squared to the power of negative 1. Notice to find the derivative, we'll have to apply the chain rule, where the inner function, which we'll call u, is equal to 1 plus x squared. F prime of x is equal to, we multiply by negative 1, that gives us negative 6. And then we have u to the power of negative 1 minus 1, or negative 2, where u was 1 plus x squared to the power of negative 2, times u prime, or the derivative of 1 plus x squared, which is 2x. Simplifying, we have f prime of x equals negative 12x divided by the square of 1 plus x squared. And now we need to determine f prime of 1. F prime of 1 is equal to negative 12 times 1 divided by the square of 1 plus 1 squared, which is negative 12 divided by the square of 2. The square of 2 is 4. Negative 12 divided by 4 is equal to negative 3. So our final answer, the slope of the tangent line of the inverse function m is equal to 1 divided by f prime of 1, or 1 divided by negative 3, which is negative 1/3. And number 2, we're asked to find the equation of the tangent line to the inverse function at the point 3, 1. Well, we have the slope and we have a point, and therefore we'll find the equation of the tangent line using point-slope form, where m is negative 1/3, x1 is 3, y1 is 1. This gives us y minus 1 equals negative 1/3 times the quantity x minus 3. Now let's go ahead and solve for y. Distributing negative 1/3, we have negative 1/3 x plus 1. Adding 1 to both sides, we have y equals negative 1/3 x plus 2. So this is the equation of the tangent line to the inverse function at the point 3, 1. Before we go, let's verify this graphically. In this graph, the original function is in blue, the inverse function is in orange. we can see the point 3 comma 1 is on the inverse function, and this yellow tangent line does have an equation of y equals negative 1/3 x plus 2. I hope you found this helpful.